And welcome to my second video on alkanes, and today we're going to be dealing with isomers. Now keep in mind, this video will not make sense unless you view part 1. Okay, so make sure you view part 1 before you move to this video. So what is an isomer firstly? Well, let me read the definitions. Isomers have the same molecular formula but different structural formula. That doesn't make too much sense if it's the first time you're doing isomers. So let me explain it in simpler language. Let's move to an example here. Here we have an alkane, okay? Right? So let's ask ourselves, what's the name of this alkane? Well, from video 1, you would know that this here is butane because the main chain here is from this C to the last C, and we can walk from the first C to the last C without without stepping on our own tracks. Okay, so it's a smooth forward walk from the first to the last. And it has how much? 1, 2, 3, 4 carbons, and it only has single bonds, so that means it is an alkane. And because of the 4 C's, well, carbons, its prefix will be BUT, and all alkanes end with the word ane. So hence, the name of this alkane is butane. Now, how about we take the C's and the H's and rearrange them? Now, keyword is rearrange, meaning that we are not adding any extra C's or any extra H's. So we're not adding any extra carbons or hydrogens. So after the rearrangement, the amount of carbons and hydrogens will remain the same, but it will look different. Now, for it to be an isomer, the amount of carbon and hydrogen has to be the same. It also has to look different, but it must also have a different name. So I'm going to do the wrong thing first. So let me scale it down and move across here now. Here we have butane, okay? So what I'm going to do now is take butane here, and let me zoom in here a little bit for you guys, and I'm going to take the N, see, and swing it upwards like this. So I'm swinging it upwards. And this H here, I'm going to swing it downwards like this to make space. Let me just neaten it up here for you guys. This looks different, okay? And it has the same amount of C's and the same amount of H's, same amount of carbon and hydrogen. But does it have a different name? For it to be an isomer, it must have a different name. I think this will have the same exact name, because even though I rearrange the C and the H's, remember, I can still walk from this C to the last C without stepping on my own tracks. So from here all the way to here, let's highlight it. From here to all the way to here, make this a little smaller, it's still 4 C's. 1, 2, 3, 4. So it's still BUT, and it's going to end with ane. So this is not an isomer. In fact, this is just the original one twisted, okay? So it's not an isomer. So let's try. The moral of the story is this, right? Whenever you're trying to make an isomer, never take one of, let me just backtrack here. Never take one of the C's on the end and rotate it upwards or downwards. So if I take this C and rotate it upwards or rotate it downwards, or if I take this C, which is also on the end, and rotate it upwards or downwards, right, it will not make a new isomer. So that's this note here. Taking a carbon at the ends, either end, and swinging it upwards or downwards does not make a new isomer. And we saw by doing it, it didn't change the name of the compound itself. So here's what we need to do. If we're going to take one on the end, we just can't simply swing it upwards. I think we should move it to more the middle. So what I'm going to do, I'm going to detach this. I'm going to take this guy here and move him over here now, right? And the one I just detached, I'm going to move him to the middle. So I'm moving him to the middle here now. Let's see if this will have a different name. So it has how much here? 1, 2, 3. That's the main chain because I cannot count 4 as the main chain. I can't say 1, 2, 3 and then go back here, because if I go back, I'm treading on my own tracks. So this is actually the main chain. So the main chain has how much in it? It has 3 carbons in it. So that's PROP. So the name of this one is PROP and ends with ANE. But it also has one branch. Okay, this is the one branch here coming out of it. So remember, when we're naming it, if there's only one branch, we pay attention to the yellow. Where does the one branch happen? Now, it doesn't matter if we count from on this side or we count from on this side in today's question, because if we count from on this side, the branch occurs at 1, 2 carbons. If we count from on this side, it occurs at 1, 2 carbons. So from either side, the branch occurs at the same point. So this one is symmetrical. So it occurs at the second carbon, and the branch itself has 1C. So if it has 1 carbon in it, it's meth. So it's METH, and because it is a branch, it ends with Y and L. So you notice by rearranging it this way, we still have the same amount of carbon and hydrogens, but it has a totally different name. So this is an appropriate isomer. So the truth is, from experience, if you try to rearrange the C and the H's, you won't find another arrangement that will give you another name. Okay? So butane only has 2 isomers, the original form and this one here, 2-methyl propane. Okay? So that's question 1 for isomer. Oh, one thing. You notice in both cases, right, for butane, let me just put something here. The molecular formula just states the amount of carbon and hydrogens it has for an alkane. So the first one here has 4 carbons, so its molecular formula will be C4, write that in capital, C4, and how much hydrogens does it have? I believe it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now keep in mind, this 10 and this 4 needs to be small 4s and 10s. Right? This is notepad, so I can't make it smaller. And for this one here, the second one here, its molecular formula, if you count up the amount of C's and H's, you will still get C4H10. The molecular formulas for both isomers are the same, but the structural arrangement is different. And that is what this definition was telling you in the first place. Isomers have the same molecular formula. You notice that they're exactly the same, but they have different structural formula. The structural formula is the actual layout of the carbon and the hydrogens. So in other words, if somebody just gives you the molecular formula, if I tell you I have C4H10, you don't know whether I'm talking about butane or 2-methyl propane, sorry. Okay, so that's the kind of disadvantage of the molecular formula. It doesn't tell you exactly which compound you are dealing with. You just know how much carbons and hydrogens you have. So that's the limit of it. So that's question 1. And keep in mind, butane only has 2 isomers, 2 versions of itself. So let's move on to question 2. All right, so let's move on to question 2. Today, in this question, we're going to be investigating the isomers of pentane, which is 1, 2, 3, 4, 5, right? So pentane has 5 carbons, and I've already drawn it out for you here. So the molecular formula of pentane is C5H12, because there are 5 carbons and 12 hydrogen. Keep in mind the 5 and the 12 needs to be small, right? Subscripts. Okay, so let's try to create some isomers of pentane. Now remember, the original one, pentane itself, counts as one of the isomers. Let's see if we can make a different isomer. Firstly, it will make no sense to take the ones on the end and swing it upwards or downwards, right? So I'm going to keep reminding you of this note here. Taking a carbon at the ends and swinging it upwards or downwards does not make a new isomer. Similarly here, if we take this one and swing it upwards or downwards, it will not make it a new isomer. So how can we make a new isomer out of this? Well, if we take, let's take this one on this end here and move it somewhere to the middle. So I'm going to take him here, move him here. Let's just detach him and move him downwards like this. So move him to the end. And he goes over, even a little trouble. All right. And we swing him like this and move him over here. Well, first of all, this here is the main chain for sure. So the main chain has 4. So he's no longer pentane. Having 4 is actually what? Butane. So let's start off with the main chain here. Let's name him now. So he is Butane. Now there is a branch. Remember, when you're identifying the branch, you have to count from the side that will have the least amount of carbon. So it will be wrong to count from on this side and say 1, 2, 3. It does not occur at the 3rd carbon, because if we count from on this side, 1, 2. So the branch occurs at the 2nd carbon, and the branch itself has 1 carbon. So he is meth, M-E-T-H, and since he is a branch, he is Y-L. So you notice it has a completely different name now. And there's the same amount of what? Carbons. And there's the same amount of hydrogens, right? So there's the same amount of carbons and the same amount of hydrogens. Okay? Great. So that's one isomer. Now I want to point out a mistake that students make. Okay? So let's make a quick note here. Right. Right. So what they will do in the exam, if they ask you to draw an isomer, they will draw this and get it correct. Now if they ask them to draw another isomer, you know what they simply do? Let me show you what they simply do. Instead of putting it here, they will just move it a little across here. And this looks completely different. So they think this is a separate or a new isomer. But let's name this. First of all, this is the main branch. So it's still butane. But you see, they might think, now remember they originally started to count from on this side. So they will say that the branch occurs at 1, 2, and 3. And they will change this to a 3. And of course, the branch only has 1 C, so it's methyl. So they will put it as this. But remember, when you are counting where the branch starts from, you have to start from the side that covers the least amount of carbons to reach it. So it's really, if you start to count from this side, it's 1 and 2. So this one and the one we just had is the same exact compound, right? So this is not a new isomer, okay? Right, so I want to clear that up. But there is actually a third isomer of pentane, and that's what I have down here. Here's what we're going to do. We are going to detach both ends. So look what I'm doing here. And then this guy here, I'm going to move him to the end here. And this guy here, I'm going to move him to the end here. So we are not changing the amount of carbon and hydrogens. It's the same amount of carbon and hydrogens. And he is going to go underneath in the middle, and he is going to go on top in the middle. Let's see if we get a different name for this one. So here is the main chain in the middle. So this time the chain only has 3. Let's see what 3 is about, right? So I'm going to write down here, right? 3, let's look up it here. 3 is PROP. So the main branch, the main chain is PROPANE. Great. Now there are 2 branches, one on either side of this C. And this one is symmetrical. So that means it occurs at the second carbon. So let's do this one first, the top one. The top one, so I'm going to do the blue part here. Look over here, the blue part. 2 dash, it only has one C, so it's METHYL. Now for the second branch down here, I'm going to use the yellow one. Dash 2 dash, and he also has one C, METHYL. Technically this is correct. I mean, if you tell someone this, they're supposed to understand. But remember, the 2 branches are the same exact size. So whenever you have 2 branches of the same exact size, you put, in this case, both branches occur at the second carbon. So it's 2 dash dimethyl, METHYL. The di means 2 of the methyl. So both methyls or both branches are occurring at the second carbon, and it's propane in the main chain, PROPANE. We had covered one like this in part 1 to this video. Okay, all right guys, so this is question 2. So at the end of the day, propane has 3 isomers. The original form, this one, right, the 2-methylbutane, and this guy here now, 2,2-dimethyl propane. So that's question 2. There are no more arrangements for new isomers for propane, for pentane, sorry. And I made a little list here. Methane only has 1 isomer. When you see 1 isomer, that means it only has the original form. Ethane only has 1 isomer. Propane has 1 isomer. Butane, which was question 1, had 2 isomers, its original form, and this one here. Let me see if I have it here in question 1. No, I probably erased it. Sorry about that, guys. Okay? And pentane, we just saw, has 3 forms. 1, 2, and 3. All right, guys, I'm going to do one more question on isomers of alkanes. Guys, so let's move on to the third and last question on alkanes and isomers. So on the screen here, let me just zoom in here, we have hexene, because it has 1, 2, 3, 4, 5, 6 carbons that we can walk from one end to the other end without stepping on our own tracks. So that's hexene. Now it should be important to know hexene has 5 isomers, and its original form, I keep saying over and over, counts as one of the isomers. I will not be doing all 5, okay? I'm just going to do one and one of the harder ones. So when we're making an isomer, right, keep in mind, once again, we're just not allowed to swing up and down a carbon at the ends. So we can't swing that one up and down, and we cannot just swing this one up or down. It will not give us a new isomer. We will end up with the same name as hexene. Okay, great. So what I'm going to do, I'm going to detach him, and I'm going to detach him. And I'm going to try to move these guys more to the middle. So how about I take him and move him to the end here, right? That's to ensure that we always have 4 lines leaving the carbon. And how about I take him and move him to the end here? And the 2 guys are just detached, right? How about one goes underneath here, and this guy goes here? Let's see if we end up with a different name. Okay, great. So let's name this guy. First of all, the main chain. The main chain is definitely this one here. So move upwards head. So the main chain has 4. By now you should know 4 is bute. B-U-T-A-N-E. Since we have 2 chains, right? This guy here and this guy here, we're going to be using the blue and the yellow. So let's start from on this side here, right? Just use this as our well, starting point for both chains. So this one occurs at the second carbon, 1, 2. So this is the blue part I'm naming here. Second carbon dash, it only has 1 C in it. So that's METH, and since it's a branch, it's Y and L. The second one, remember this is our starting point for both chains. If you have 2 chains, you're only allowed 1 starting point. So the second chain occurs at 1, 2, 3. So it's 3 dash, right? And he's also 1C, so he's METHYL. All right. We have 2 chains of the same exact size. So we have to simplify this name. 2, 3 di METHYL butane, B-U-T-A-N-E. All right, guys. So this is just one of the isomers of hexene itself, and in both cases, the original hexene had 6 carbon, if I'm not mistaken, 6 carbon and 14 hydrogens, and 2,3 dimethylbutane also has what? 6 carbons and 14 hydrogens, right? So it meets the criteria for an isomer. It has the same amount of carbons and hydrogens, the same molecular formula, in other words, and they look different. They have different structural formulas, and because of the different structural formulas, they have different names. Okay, and here's a list of alkanes and the amount of isomers each one has. I know there are other isomers like heptane and nonane and dectane, but for your multiple choice purposes, just remember up to hexene, right? And the amount of isomers it can have. Okay, guys, so I really hope this was helpful. This is not the end of alkanes, believe me. I still have to do uses of alkanes, the reactions of alkanes. And when that's finished, I have to move on to alkenes, which is different to alkanes, and then alcohols, and then polymers, and the list just goes on. All right, guys, so, and don't forget to read the description in the video. If you need extra lessons in almost any subject, you can contact me. My number is in the description. And of course, don't forget to subscribe, like, and well, share the video if you think it was useful. Take care, guys.